Hi everyone, this is Mrs. GA, and today we're going to be graphing sine and cosine again, but today we're going to be working with translation. So remember, shifts left, right, up, or down. Before we get started, I have a quick warm-up for you guys, so please pause the video and give these two a try, and then we can check your answers in just a few moments. Alright, so go ahead and check your work here. You can see that I started with the 5 key points from our parent function. So here's the 5 key points for cosine and then for sine. And then for the first one, it's vertical stretch by a factor of 3, which is why I multiplied all my y values by 3. And then for the second one, it's a vertical reflection over the x-axis and a vertical stretch by 2. So I multiplied my y values by -2. So you can see I did the parent function with dotted red just to show the difference between the original function and then that vertical stretch. And then for sine, here's our original function, so you can see that it was reflected and stretched. So here's a quick reminder of all of the transformations that we talked about for the sinusoidal functions. The ones we talked about in the last lesson were that vertical stretch. So if the a value is greater than 1, or vertical shrink if it's between 0 and 1. And remember, we call that an amplitude change in trigonometry. So that's what we just saw in the warm-up. And then we also have that minus sign out front. So whenever you see that, it is a vertical reflection over the x-axis. So you saw that also in the warm-up. So the two that we're going to be practicing today are horizontal translations. So that occurs when you add or subtract from x. So notice that it's grouped inside the parentheses with x. So that causes your graph to shift left or right. And in trigonometry, we call that a phase shift. So we can just do that. We can achieve this by simply adding or subtracting h from all of our x values from our coordinates. Just remember, due to that negative sign, it actually moves in the opposite direction that you think. And then the last one we have is that plus k at the end. So this is a vertical translation, so it will shift your graph up or down, and we can achieve this by adding or subtracting k from all of the y values. I do want to remind you also, when we're doing the transformations to your coordinates, we kind of follow PEMDAS when we are applying them. So anything involving multiplication, we should do that first, and then we should add or subtract. So again, it's just like PEMDAS, we multiply before we add or subtract. All right, so for each of these examples, we're going to graph 2 full periods. So once you graph a period to the right, you can kind of just repeat the pattern going to the left. We're going to name at least 5 exact coordinates, and then we're going to determine the period, the amplitude, and the maximum and minimum values. Okay, so here I see that we have our sine function, so we can start with those 5 key points from sine. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. So remember, sine starts at 0, and then if you break it up into those 4 quadrants, it goes up, back to 0, down, back to 0. And then let's see what transformation we see. So we see a plus 1. It's not grouped with x, so we know it's a vertical translation. So this is actually going to shift our graph up 1. And we can achieve that by adding 1 to all of our y values. Again, because it's vertical, we add it to the y values only. And that gives us the coordinates 0, 1, pi over 2, 2, pi 1, 3 pi over 2, 0, and 2 pi 1. So let's plot those points. Here's 0, 1, pi over 2, 2, pi 1, 3 pi over 2, 0, and 2 pi 1. So we see we have our sine graph has just simply been shifted up 1 unit. So we can kind of continue this pattern going to the left. So we're going to go down, middle, up, middle, just like this. And there you go. So our amplitude, remember, is the distance from the midline either up to a maximum or minimum. Since there wasn't a vertical stretch or shrink, the amplitude should not change for the parent function. So again, the distance from the midline up is simply 1. So that's our amplitude. Our period is unchanged. It's still 2 pi. It takes 2 pi units to complete a full cycle. And then our maximum value is now 2, and our minimum value is 0. Okay, let's try another one together. Here we have a cosine function. So we're going to start with the 5 key points from cosine. Maybe I'll do them down here this time for a little more space. So remember, cosine starts at the top. So it's 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then back to the top, 2 pi 1. So that's from our parent function. And here I see 2 transformations. The first one that I'm going to look at is the multiplication, that a value out front. So this is a vertical shrink because it's less than 1 by a factor of 1/2. So we can achieve that by multiplying all of our y values by 1/2. Again, just the y values because it's vertical. So let's see what that gives us. So 0, 1/2, pi over 2, 0, pi negative 1/2, 3 pi over 2, 0, and 2 pi 1/2. And then I see that we have that minus 2 at the end. Since it's not grouped with x specifically, I know this is going to be a vertical translation. So this is actually going to shift our graph down 2. And notice that we're going to do this after we've done the multiplication from our transformations. So now we can do minus 2 from all of our y values. Okay, so this is going to give us 0, negative 3/2, pi over 2, negative 2, pi negative 5/2, 3 pi over 2, negative 2, and then 2 pi negative 3/2. So let's plot our points. And again, you're just going to need to estimate for 3/2 and 5/2, or you could change the scale of your graph if you really wanted to. Either way is fine. I'm just going to leave the scale of the graph how it is. So we have 0, negative 3/2, which is negative 1.5, and we have pi over 2, negative 2, pi negative 5/2, 3 pi over 2, negative 2, and then 2 pi negative 3/2. So it looks like this. So you can see it's super squished down. It's very flat due to that vertical shrink by 1/2, and then everything has also been shifted down 2. So notice really quick that the midline of our graph is now at negative 2, where for the parent function, the midline is usually at 0. So you can see it's been shifted down 2, and again, it's really flat. So we still have that same pattern. We have top, midline, bottom, midline, top. So we can kind of continue that except going backwards. And again, here's our midline. So we have the top, so we'll go middle, bottom, middle, top. So just like this. So we're kind of just completing the pattern going to the left. Okay, so now let's name our key features. So our amplitude, again, is the distance from the midline to the max or min. So you can see that distance is 1/2. Another little tip, it's always going to be that a value out front. That's going to be the amplitude of our function. Our period is still 2 pi. That's unchanged from the parent function. So if you measure maybe from this top to this top, it takes 2 pi units to complete the cycle. Or maybe go from the minimum to the minimum. Here to here, that's still 2 pi units. And then in this case, our maximum value is at negative 3/2, and our minimum value is at negative 5/2. All right, so now we're going to try one that has a horizontal shift. So it's going to shift left or right. So again, this is a sine function. So let's start with our key points for sine. We start at the middle, and then we go up to the maximum, back to the middle, down to the minimum, and back to the middle. So those are 5 key points. and then we can see our transformation right here. Since we are subtracting pi over 2 from x, it's actually going to shift our graph to the right. So remember, it moves in the opposite direction. So it's going to shift to the right pi over 2 units. And I know it looks weird to shift by pi over 2 units, but remember, pi just stands for approximately 3.14. And with these types of functions, it's really common for especially a horizontal translation to shift with some form of pi. So that means that I'm going to add pi over 2 to all of my x values. And we're doing it to the x values because it's a horizontal transformation. So we do plus pi over 2, and again, just to our x values. Okay, so this gives us pi over 2, 0, pi 1, right? Pi over 2 plus pi over 2, half pi plus half pi. This becomes 3 pi over 2, 0. This becomes 2 pi, negative 1, and then 5 pi over 2, 0. So that will go a little bit off our graph, but that's fine. So let's plot those points. So we have pi over 2, 0, pi, 1, 3 pi over 2, 0, 2 pi, negative 1, and then let's just call this 5 pi over 2 right here. Okay, so let's draw in our curve. So that's one full period. And we can continue that pattern going to the left. So we're at the midline, so we'll go to the minimum, midline, maximum, midline. And there you go. Now I just want to quickly sketch in, this is what the parent function looks like if you plotted the original 5 points, just so you can see that our graph has in fact just been shifted over to the right by pi over 2 units. Okay, so let's look at the key features. So our amplitude is unchanged. It's from the midline up to a maximum or down to a minimum. So that distance is still 1. And again, that's because there was no vertical stretch or shrink. Our a value is 1. The period is still 2 pi. That's still how long it takes to complete a cycle. And then our maximum is positive 1 and our minimum is negative 1. So here everything was just simply shifted to the right, again by pi over 2 units. Okay, let's try this next one. We have a cosine graph here, so I'm going to start with our 5 key cosine points. So 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi 1. Let's start with the transformation involving multiplication. So this is going to be a vertical stretch by a factor of 4. It's also going to result in an amplitude change, as we've learned. We can apply this by multiplying 4 to all of our y values. So let's do that first. So we get 0, 4, pi over 2, 0, pi negative 4, 3 pi over 2, 0, and 2 pi 4. And then we see one more transformation here. It's grouped with x, and it's addition or subtraction, so it's a horizontal translation. This is actually going to shift our graph to the left, remember opposite direction, by pi over 4. So just one key thing here, look at the scale of your x-axis. If this is pi over 2, halfway in between is pi over 4. So we are actually counting by pi over 4 here. So we can achieve this transformation by subtracting pi over 4 from all of our x values. So here we do need to be careful. We are working with some fractions, but we can work through it together. So this just simply becomes negative pi over 4, 4. If I have half pi and I subtract a quarter pi, that gives us a quarter pi. So pi over 4, 0. 1/2 minus 1/4. Here, this is saying 1 minus 1/4, so it's 3 pi over 4, 3/4 pi, negative 4. Here we have 3 pi over 2. which is here, and then we're subtracting 1/4, so it's actually 5 pi over 4, and then 0, right? It's pi plus that 1/4, so 5 pi over 4. And then this one, we have 2 pi, which is 8 pi over 4, minus 1 pi over 4, so that gives us 7 pi over 4, 4. And for these trig functions, we would always write them in this form. We would never write it as a mixed number. Like I would never write this as 1 3/4. So we should make sure you're comfortable writing these as fractions. Okay, so now that I have my new points, let's plot them. So again, I'm actually counting by pi over 4 on my x-axis, so this should be pretty easy for us to graph. So we have negative pi over 4, positive 4, so way up here. And then we have pi over 4, 0. Then we have 3 pi over 4. So again, if this is 1 pi over 4, this is 2 pi over 4, this is 3 pi over 4. And then we have negative 4, so way down here. 5 pi over 4, 0. And then 7 pi over 4, 4. So it looks like this. And notice that our graph should kind of curve around and go back down. It's not going to keep going straight up, so please don't draw an arrow straight up. So you can see here's our midline. Our midline is still at 0. Our graph has simply just been shifted over to the left, and it's really stretched up. So let's see if we can continue this pattern moving to the left. So since I'm up at the maximum, my next point will be at the midline, and then down at the minimum, and then the midline, and then it does go a little bit off our graph. We can just estimate where that is. So it looks like this. And there you go. So again, if you compare this to our parent function, which looks something like this, you can see that our graph has been shifted over to the left. So you can see where a maximum used to be. Now our maximum is shifted to the left, and our graph has been stretched vertically. So our amplitude, again, is 4 because of that vertical stretch. It's also, again, the distance from a midline to a maximum or to a minimum. Our period is still 2 pi, so the distance, let's say, from here to here. This is negative pi over 4. This is 5 pi over 4. That distance is still 2 pi. So we haven't been doing any period changes, if you've noticed. And now our maximum value is 4, and our minimum value is negative 4. Okay, let's do one more together. So here we have our cosine function. So let's start with our 5 key points for cosine. 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then 2 pi 1. And we have two transformations. First, I see that we're adding pi to x. So this will shift our graph to the left, remember opposite direction for anything grouped with x, by pi units. And then I see this minus 2 on the outside, so this is going to shift our graph down 2. And since these both involve addition or subtraction, we can actually apply them both at the same time. So this horizontal one, since it's grouped with x, is going to affect our x value. So I'm going to subtract pi from all of our x values to shift it to the left by pi units. And then this is going to affect our y values because it's vertical. So I'm going to subtract 2 from all of our y values. So again, here we're going to be working with some fractions, so make sure that you're comfortable doing that, and we'll keep it in fraction form, no mixed numbers. So our first coordinate will become negative pi, negative 1. And then our next coordinate will be negative pi over 2, negative 2. And then we have 0, negative 3. And then we'll have pi over 2, negative 2. And then pi, negative 1. So let's plot those points. Here we have negative pi, negative 1, negative pi over 2, negative 2, 0, negative 3, pi over 2, negative 2, and pi, negative 1. So there's one full cycle. I know it's a full cycle because I'm going from a maximum, I hit a minimum, and I've returned to our maximum. So you can see here, our midline is right here. It's been shifted down 2. So you can generalize that a vertical shift is going to move your midline. I see that our amplitude is unchanged because there's no vertical stretch. So our amplitude is still 1. Our period is still 2 pi. Our maximum value is now negative 1, and our minimum value is now negative 3. Let's see if we can kind of continue our graph. We'll do a little bit to the right and a little to the left. So just kind of follow that pattern of going from maximum to the midline here to the minimum value. And we'll do a few points to the left, minimum, midline, and then minimum. So I'm going to just do however much fits on your graph for this one. You can see this actually has 2 full cycles because I'm starting at a minimum, returning to a minimum, and returning to a minimum. All right, so now I have one for you to try on your own. So please pause the video and give this a try. And when you're done, you can hit play to check your answer. All right, go ahead and check your work here. So here's my 5 starting points. So the first thing you need to do is apply that vertical stretch. So you can multiply all of your y values by 2, and then you can apply your translations. So to shift your graph to the right, pi over 2, you can add pi over 2 to each x value, and then to go down 2, you can subtract 2 from all your y values. So you can see that our midline has shifted down 2, and then all of our points have been shifted to the right by pi over 2. And our graph is a little bit stretched out due to that amplitude change. So just remember, we always apply transformations involving multiplication before addition or subtraction. All right, here's the last example. So again, please pause the video and try this on your own. And when you're ready, you can hit play to check your answers. Okay, go ahead and check your work here. So we have 2 transformations. Our graph is shifted to the left pi over 4, which is why I subtracted pi over 4 from all of my x values, and it was shifted down 1, which is why I subtracted 1 from all of my y values, giving me these points. So remember, the scale of my x-axis is by pi over 4, so it's nice and easy to plot my points, and make sure that all of your coordinates are using these mixed fractions, such as 5 pi over 4 and 7 pi over 4. So you can see our amplitude is 1. There was no vertical stretch or shrink, and that's the distance, again, from the midline to a maximum or minimum. Our period is still 2 pi, and now our maximum value is at 0, and our minimum value is at negative 2. All right, that is all for today's video. Thank you so much for watching.